Hello everyone, welcome back to my YouTube channel. My name is Sunny Savita and in this video we'll see that how we can implement RAG application by using Llamaindex and Mistral. So guys, so far I shown you the RAG application by using the LangChain, and before that I shown you that how you can create RAG application from scratch using Python. So there also I involved Llama 2 model and Llama concept. If you haven't checked guys, please go and check. So let me show you my YouTube channel. There I will show you all the video one by one. So here guys, you will find out each and every video on my YouTube channel with respect to this RAG application. So inside the playlist you can also check. I created one separate playlist for this RAG application where you will find out all the tutorial so far whatever I have created on top of the RAG. So RAG from scratch, RAG by using LangChain, RAG by using LangChain and open source model. Everything you will find out over here. So let's begin. Let's begin with one more new framework, that is Llamaindex. So before this tutorial, even I also created the video on top of the Llamaindex. If you will go and check with my video section, so here you will get the video with respect to the Llamaindex. So introduction about the Llamaindex and project setup for the Llamaindex. Already I taught you this thing. Apart from this one, you will find out one project as well which I took in the live session. So QA system using Llamaindex and Google Gemini API. And apart from that, you will find out this Llamaindex versus LangChain. So enough amount of theoretical content I provided you with respect to the Llamaindex. Now it's time to build something by using Llamaindex and open source model, that is Mistral. So let's begin. Let's start. So first of all guys, what you need to do here, you need to open your collab. So here I already opened my collab and here you will find out. So I written the heading RAG application using Llamaindex and Mistral. So guys, here first of all you need to connect with your GPU. So if you haven't connected with your GPU, please do it. You just need to go inside this runtime and change your runtime and then save it and then finally connect it. Okay. Now guys, I'm doing it from starting. So step by step, one by one, I will write each and every line of code. So sometimes I will be writing or sometimes I will be just copying and paste. So guys, and don't worry, this notebook you will get inside my GitHub repository. So let me show you my GitHub repository where I'm updating all the material related to this particular tutorial. So here is my GitHub repository guys. The name is in-depth generative AI. So once you will go through with this GitHub repository, here you will find out all the files and folder, whatever I have used so far, whatever I have created so far. So please go and check, please try to download in your system and then do the experiment. Now I hope my system is connected, my collab is connected. Now let's try to implement one by one. So first of all guys, we have to install something and here we are going to install this particular package. So what is the package name guys? The package name Llamaindex LLM hyphen Hugging Face. So this package is required. This package is required for creating this project. And here apart from this one, we required some other packages also. So I will show you that as well. Now the package installing. Until that, I can write some other line of code. So here one more package which is required, that is a Llamaindex itself. So here the second package is Llama-index. So let me install this one also. And yes, you can install by using this exclamation mark, or else you can use this percentage. Both are fine. Anything you can use for installing the package inside the collab. Now what I'm doing here, so after installing the package, right, here I'm going to import something. If you want to like write the code for the exception handling logging, so definitely you can do that, because in one video I see the comment recently, so people are saying, sir, can I write the exception handling or logging for this particular project or for this particular implementation, notebook implementation? Yes, for sure you can do that. Okay, you can write the exception handling, everything you can mention inside the try cache. You can maintain the log inside the log file. So that I will show you in the next class. One more notebook I have prepared with all of you, so with a different model and different text stack, so that I will show you soon. Now here Llamaindex is getting installed. Now here guys, one more thing. So the heading you can see Llamaindex with Mistral AI. So in the previous tutorial also, in this particular video, I shown you this Mistral AI. So this Mistral AI, actually, I was using the Hugging Face Hub for loading this Mistral model, Mistral 7 billion model. Now in this particular tutorial here, we are not going to read this model using Hugging Face Hub. Instead of that, we are going to load it inside the memory. So here I am doing each and every type of experiment so that you can explore each and everything over here. So according to your requirement, you can test it. Okay, you can use it. Getting my point? Now what I'm doing here, so here I already installed, so here I installed this Llamaindex. Now it's time to write some code. So first of all, guys, here what I'm going to do, I am going to import few module. So this is my module, guys, two module. First is vector store index, the second is simple directory reader, the third one is the third one is Hugging Face LLM. So these three classes I have imported. And guys, please watch this tutorial till end. I will give you like detailed knowledge regarding this particular class, because this class I will show you from the GitHub directly, from the Llamaindex GitHub directly. Okay. Now what I'm doing here, I'm just loading this three classes from this particular module, llamaindex.core, llamaindex.llm.huggingface. Okay. Now here what I'm doing, so guys, for creating the RAG pipeline, I think you know about the RAG, Retrieval-Augmented Generation. In my previous video, I have shown you this particular architecture, and even I have implemented this as well. So guys, here this architecture, it's a RAG architecture where we have three processes. First is called data ingestion, second is called retrieval, and the third is called generation. So if you don't know about it, please go and check with my previous video. Okay. Now what I'm doing here, so here I will be required the data, and for that simply I'm creating a directory. So my directory is my data directory. Now here I am keeping some data inside this particular directory. So I have already downloaded one PDF, and that PDF I'm going to upload over here inside this data directory. So my PDF name is what? Machine Translation with Attention. It's a research paper. Yes, easily you can check with a Google and definitely will get it. So here you can see my data is uploading. Now my data is available. Simply I can read my data now. So for that also I have code. So this is the code, guys, for loading the document, for loading the data. So simply I'm reading the directory over here. So simply I'm writing simple directory reader dot means what? Current directory, and here is my data folder. From there I am reading that particular PDF. So once I will execute it, so here in this particular variable, I will find out my data. So let me show you how my data looks like. So here is my data, guys. So simply you can read it, simply you can check it, and you can write this thing inside the print statement also. So you won't get that unnecessary parameter like slash and all. Now here, if I'm writing a print n, so simply you will find out this data. Okay, this is the data, and it is inside the list. Okay, you can extract from this particular list. This is the entire data. I hope you got till here how to load the data. It's not big deal, it's not a very big thing. And now what I'm going to do, now I am going to implement further code, right? So here, guys, after implementing the data, sorry, after getting the data, I'll be required the prompt. So here I am keeping the prompt. Now why this prompt and all it is required, I will come to that. First of all, let me execute it. So here you will find out the prompt template inside the Llamaindex also, similar to the LangChain. Getting my point? So here inside the Llamaindex also you will find out this prompt template. So from llamaindex.core, I am going to import prompt template. Now here is what? Here is my system prompt. Means what? So here I am giving the instruction to my system. So whenever you will go and check with any application with respect to the LLM, there you will find out three things, right? The first thing is called user. The second thing is called assistance, and the third one is the system, right? So here I kept one. So here is what this one. So here, guys, you can see one is Stack Overflow link. There I am explaining you with the example. So just look into this particular example, just a JSON format, right? So here you will find out. So here is a role. Okay, role. We are selecting as a user. Directly you can check with the playground and all, and simply you can set a different role. this playground is available over the OpenAI API and even the Llamaindex as well. Sorry, Llama 2 as well, Meta, right? So here you can define the different type of role, and based on that you can generate the data. So role, here I'm defining a user, and here you can see this is my content, right? Means my job. Now here this assistant means what? System. That LLM is called system. Sorry, the LLM is called assistance. Okay, the LLM is called assistant, which is responsible for generating the output. So here this user is asking something, and this LLM means this assistant is generating a response. Now what is a system? So system means that developer, right? Means the entire system, okay, which is responding to me, and this assistant actually it comes inside the system. So here you will find out system is nothing, it's a overall infrastructure, overall system, overall development environment. So we can set the behavior of this particular environment. So the same thing you will find out over here as well. Each and everything I am trying to give you along with the example, so you won't be confused, right? So this is my system prompt, and here I am defining this particular syntax, means assistant and user. This by default I'm taking from where? From the backend side. So this thing I have already mentioned it over here. So this is what this is my prompt. At the end I will give you the clear cut idea of the architecture if you haven't seen my previous tutorial, guys. So why I'm defining this prompt and all, everything you will getting. Now what I'm doing, so here guys I will be required the LLM. So now what I'm going to do here, I'm going to load my model from where? From this Hugging Face LLM. Okay, so guys in my previous video, if you will so here if you will go and check with this particular notebook which I implemented in my previous class, so directly I was reading the model. Okay, directly I was reading the model from Hugging Face Hub. I mentioned the API key, Hugging Face API key, and directly from there itself, I was reading the data. Sorry, I was reading the model. Let me show you that. So this one, right? Now here what I'm doing, now in this particular notebook, I'm loading the model in my memory, in my hardware. From where? From the Hugging Face directly. And here Llamaindex allow you this particular thing. So this Hugging Face LLM actually it is available inside the Llamaindex. Let me show you, I already imported it. So over here if you will look into the import statement, so already you will find out this one Hugging Face LLM from where? From a Llamaindex. Now guys, if you don't believe to me that this class inside the Llamaindex or not, let me show you that. So here guys, this is a raw implementation inside this Llamaindex. Inside this Llamaindex you'll find out the raw implementation of this Hugging Face LLM. Now here you will find out all the parameters, whatever parameters we are going to define inside this class. Getting my point? Yes or no? I think yes. Okay, so here this class Hugging Face LLM. Now here you will find out all the parameter, whatever parameter actually we are going to mention over here. Now let me show you the all the parameter, and along with that each and every description. So this is all the parameter. Model name, in our case it's going to be a Mistral. Tokenizer name, okay, it's again in our case also is going to be a Mistral. Context window, max token, model KWRGS, generate KWRGS. KWRGS means keyword argument. Then message to prompt, then complete to prompt, completion to prompt, then device to map, right? And here you can see this is the method, like complete method we are going to call, and here we are getting a response. Now guys, let's try to understand the meaning of all these variable which we are going to initialize inside the class, right? So here you will find out the description or detail of it. Now here you can see model name. So what is the meaning of it? The model which we want to use directly, or which we want to load directly from where? From the Hugging Face. Now here you will find out the second one. The second is what? Context window. Now what is the meaning of the context window? The maximum number of tokens available for the input. How many tokens you are passing to the model in one sentence? How many tokens, how many maximum token you can pass to the model? Okay, that we are going to define over here. The third one is what? The third one is a default number. Sorry, this one, maximum number token. Maximum number token means what? The maximum number of token which we want to generate. Getting my point? I think yes. Now system prompt, right? So description, the system prompt containing any extra instruction or context means we are defining a behavior of the system here. Okay, now query wrapper prompt, just read this detail. The query wrapper prompt containing the query placeholder. The model card on Hugging Face should specify if this is a needed, should contain a placeholder, right? So here what we are doing, so we just need to mention that a particular uh, syntax. Okay, so here you can see query wrapper prompt. So what we are passing over here, this query wrapper prompt, this one, this we have initialized now, this one query wrapper prompt, and here we are passing this user assistance and this query string. Automatically it will take, automatically model will take whenever we are passing any sort of a query. Getting my point? So we just have to define this prompt template along with this particular syntax, and it is also from the Llamaindex. It's a high level thing which I have written, but in backend so many things going on. I can show you that code as well, but I don't want to confuse at all. So here I'm just showing you the Hugging Face LLM parameter so that you can understand till one level, and rest of the thing you can explore. Okay, now here you can see, so we have this default Hugging Face model. If you are not going to write, sorry, tokenizer name means whatever name, basically whatever model you are going to use. If you're not going to use anything, so I think by default it will be a GPT-1. Device name, which one, like whether you are going to use the CPU or GPU, right? Stop ID, where you want to stop, means you have the token now, right? So token will give you the IDs of the tokens. Okay, so where you want to stop, so you can mention the specific IDs also if you want them. Tokenizer output, tokenizer KWRGS, model KWRGS, generated KWRGS, right? Each and everything you will find out over here, each and every description. So guys, this link I am keeping inside your notebook so that you can get it from here. You no need to find it out from your side, because everything I am doing behalf on you here. So this is the link, guys. You can go and check, and peacefully you can read each and every description from here. Now it's time to load the model. So let's try to load the model, and then guys, after that, after loading the model, what I will do the further thing. I will initialize my vector database and all. Now one more thing I would like to highlight over here. So whenever you are going to load this model, now here see the size of the model. So in backend actually they are using bits and byte configuration. If you don't believe me, here you can check with this a particular link. So here in the backend actually they are initializing this bits and bytes configuration. This one, this bits and bytes configuration is nothing, it's a quantization method where actually you are going to reduce the size of the parameter so that you can load inside your memory. Means here we are not doing a distributed processing, means we are not going to load our model, this very huge model, on the distributed GPU. Here we are going to load it on the single GPU, and because of this bits and bytes it's going to be possible. Getting my point? So here guys, this bits and bytes is going to be implemented in the backend. I will create one separate video on top of it, and then you will getting it. But here just for your knowledge, how we are able to load this much of bigger size inside the hardware, inside the memory. Okay, now here you will find out the RAM, 12 GB RAM, and in that RAM we are able to load this 9 or maybe like 14 GB of model. How it is possible? How? Because of this bits and bytes configuration. It is quantizing the entire model. Now, what is the quantization? What is LoRa, QLoRa, PEP? Each and every thing we're gonna talk about, right, in our upcoming session. So stay tuned, and if you are liking the session, then please hit the like button, please subscribe the channel, and please share with your friend whoever required this type of project and the content. Now we are able to load the model. Now it will take some time until I can write my other line of code. Now guys, along with the model I will be required the embedding model. If we are not going to load any embedding model, so by default it will take the OpenAI embedding model, but we don't want to use the OpenAI API key and all, because many people don't have that credit card and all, which where we can add on this thing, right? So here we simply going to load the embedding from the Hugging Face itself. Now one more thing I would like to tell you, if we are talking about the Mistral, guys, so Mistral will provide you two type of model. One is the open source and the second one is the paid one. So whatever model you find out inside this optimized section, small, large, embedded, it's a paid one. For that you will have to use the key, and for that you will have to pay as you go. The second one is the open source. So this model 7B and Mistral X into 7B. So 8x 7B actually. This is the paid, sorry, this is the free one. Okay, this is the free one, and you can access it from the Hugging Face. Now here you can see my model is done. Now my requirement is getting downloaded. Until what I can do, I can write the code for the Hugging Face embedding. Guys, here I'm not writing by myself because I'm more focusing to explain you the thing so that you can understand. If I'm going to write now, so in between I will be doing the spelling mistake and all, and definitely we won't be able to complete this on time, means within like 30 to 40 minutes. So here I return it inside my notepad. I'm just copying and paste. That's it, right? So don't be offended, sir, why you are not writing. You should write it. I will do that in one live session, but not here in this recording. So here, guys, is my embedding model, which I am going to load from where? From this, all from this Hugging Face. The model name is what? All MPNet base P2. You can read more about this model from the Hugging Face hub, and rest of the thing I have explained you in my previous tutorial. So you can go and check. Now what I'm doing, I'm loading my embedding models. So it will take some time, and until then what I can do, I can keep two more things over here. So one is what? One is the service context, and the second is what? Second is the vector store. So here, guys, I have imported two new things. First is what? Vector store. The second is what? Service context. Now first let's understand about this service context. So service context is nothing actually. Here the service context, it's a simple data class. Now why they have created this simple data class? First of all, let me show you what is a data class. So here, guys, again I'm coming to this Llamaindex GitHub. So here you will find out this service context class. Service context, this one, guys, service context data, and it's what? It's a data class. Now here you can see, you can read the description of it. It's nothing, it's a utility class. Means we are using this class just for initializing the variable. That's it. Means if you want to initialize the LLM, we are doing that. We are going to, if you want to initialize the prompt, we can do that. Embedded model, we can do that. Here we are just going to initialize the parameter. You can simply search about the data class in Python. It's a simple class just for initializing the variable. Okay, so what we are doing, we are initializing a variable, or you can say the parameter, anything is fine. So now we can use this parameter anywhere. So it's a simple data class, and here you can read the description. So let me give you this particular link over here so that later on you can go through with it. And don't worry, guys, I will give you this entire notebook so that you can practice it by yourself as well. So here what I'm doing, I'm creating a service context. Now let me do it. And after creating this service context, guys, now the very important thing. So here what I'm doing, guys, so here I am writing this vector store index. What is the meaning of this vector store index? Again, let me show you the raw implementation of it. So here, if you will go and check with the GitHub, you will find out so many methods over here with respect to what? With respect to the simple, with respect to the vector storage. I think in my previous session, I shown you that we have a different vector storage. Let me write it down over here so that you will get the clear cut idea. So here, guys, what I'm going to do now, what I can do, guys, just wait. Let me open my Blackboard, and here I can show you the simple architecture. So just focus here. Now let's say we have the data. This is what? This is my data. I'm just revising the architecture. This is what? This is my data. This data actually I'm creating into the different chunks, right? So after doing the chunking, now what I'm doing, I am creating an embedding, right? So I am creating the embedding from here. So here is what? Here is my embedding. Similarly over here as well, embedding. Now similarly over here, embedding. Chunk means what? So we don't want to like provide the entire data, so that we are going to divide into the multiple sentences. This entire data, entire PDF, multiple sentences. Okay, we are going to divide it. Then after creating this embedding, what I will do, I will store it inside this knowledge base. So here is what? Here is my one knowledge base where I am going to store my entire data in the form of embedding. Now let's say user is asking something. So here is what? Here is my user. This is what? This is my user. Now this user is asking something, is he's doing a query. So first this query will go over here, right? So this is my query. Now query will go over here in the form of what? In the form of embedding. In the form of embedding. Embedding is nothing, it's a numerical representation of the data. Then from here actually I will get the similar search. Okay, so here I will get the top similar search, similar search. Okay, top similar search, you can say rank result, you can write the rank result also over here, rank result, or you can say top retriever. Okay, so this is my retriever actually, so you can say retriever, top retrieval, or you can say top similar search, you can say rank result, whatever. Now this thing I am passing to what, to the LLM. So here this thing I am passing to the LLM, and from here my response is going to be argument, and again I am passing to the user. So this result, okay, this result plus prompt, this result, result, this result plus prompt, this result plus prompt I am passing to my LLM, and then basically we are going to generate the final response. So this is the overall system, right? So this prompt, the prompt template which I defined, I'm using over here. This result which we are getting from the database, from the knowledge base. So this result and prompt both I'm passing to my LLM. In my case, the LLM is Mistral. Now this knowledge base actually, it could be anything. It could be any SQL based database. It could be any NoSQL based database. Okay, or it could be any vector database. Okay, or an in-memory database, means in the memory itself. So some like framework Llamaindex, his tech, or this LangChain, they have created their own classes. Okay, they are going to store the data in the form of key and value in the memory itself. Okay, so in memory. So here in my case, actually, in my case, you will find out this vector store index. It's nothing, it's a in-memory database. In memory itself, in the memory itself, in the hardware, whatever hardware we are using now. So there itself, I'm going to itself I'm going to store the data in the form of key and value. That's it, nothing else. And along with that, you will find out the indexes also, along with each and every query. And everything is going to happen in the backend. They have written the code. Even you can check inside the GitHub as well. Okay. Now here chunking we are doing, we are loading the model tokenizer only. We are doing the embedding by using that Hugging Face model, that open source model, and then we are storing where, inside the in memory. Okay, in memory itself, in memory database, and then rest of the process. So this entire process is called Retrieval-Augmented Generation, and we have lots of use cases and all of it. You can simply go and check with the previous video. Now what I'm doing here, guys, so here now let me perform the further step. So here I'm going to store the data, and we are going to create an index with respect to that particular embeddings, right? The embedding which we are going to be stored over here. Now you can relate each and everything over here after going through with that particular architecture, right? Don't worry, again I will give you the quick revision after completing this one. Now the final and the last step what I'm doing, so here actually I am going to pass it. So I'm going to call one method on top of it, on top of the index, as query engine. So I want to use it as a query engine. Now simply I can ask my queries over here. So guys, simply I can write over here, let me write query underscore engine. Okay, and simply I can write my query. So this PDF actually, it was related to the attention, machine learning with attention, right? So sorry, machine translation attention, neural machine translation attention. So simply I can ask over here, what is attention? So it's a PDF chat, it's a PDF talk with PDF, or it's a simple rag system. Okay, now along with Llamaindex and Mistral. So here my main motto to show you this particular process, right? So let me run it and let me check whether I'm getting the response or not. So here if I will run it, so here you will find out that we are getting a response. So here it's just showing some sort of a warning, you can ignore it, or then you will get the response. Until I can write some other questions as well. So here let me write the question, how attention is different, how attention is different from RNN LST, right? So let me ask this query as well, and let's see what I will be getting over here. So here guys, you can see it is generating a response. It is taking some time, but at the end maybe it will give you the result. Let's see. And here my RAM uses is going up. Currently it is using 5 GB of RAM, right? If you are facing any sort of a issue with your RAM and all, if you are going to implement any organizational use case or any real-time use case, in that case you can take the Google Colab Pro access as well. Otherwise, we have other cloud services and all. If you want to take any sort of a machine, that paper spaces, they are AWS, Azure, GCP also provide you the GPUs, right? So you can go and check with the different platform and all, and definitely you will get that. So here you can see we are getting a response. So it is generating the response, guys, and here the response is, it's a quite large one. So response is this one. Attention is a mechanism used in, so from there actually we'll have to extract this response, okay, if you want to collect this particular response. So attention is a mechanism used in machine translation to tend to utilize of hidden state of the input sequence during the decoding phase. Great, guys, I'm getting the response. Now you can see rest of the other thing, metadata and all, so we don't require this thing. I think it is providing the multiple output. Okay, so it is providing a multiple output. I think we can restrict it also till the one output as well. So here I think we are getting top three output. Yes, yes, yes. So we are getting top three output over here. Similarly with this as well. So here, guys, you can see we are getting top three output, but yes, anyhow it is generating the response. Now you can set like maybe they will have to mention some parameter. With that I can restrict the output over here or somewhere. I will have to check that. But that thing I have shown you in my previous implementation. Okay. Now you can see, so in the previous implementation you will see that I was just getting the one answer. So but I will have to check with this particular framework how I have to restrict it with the one output. Now you can see how attention is different from the RNN, so you can check with the response. We'll have to extract the response from here. Now where is our response? Let me check. This is our attention is different from RNN in the sense that allow the model to focus and pay more attention to the relevant part of the input. Yes, guys, it is generating output and it is good as well. So I hope, guys, you got to know that how to write a pipeline, how to create a pipeline by using this Llamaindex and Mistral. Let me give you the quick recap of it. So this library is required. Now here, this like import statement is required. Then I loaded the data. You can load the multiple document also. This is my prompt template which I want to pass to my LLM along with the retrieval process, along with the retrieval data. This is my LLM, guys, Mistral I'm using over here. Along with that, this is my Hugging Face model. Okay, this is my Hugging Face model. Let me show you that. This one. Apart from that, you will find out the service context. This is nothing. This is just a initializer utility function, utility class, and here you can see the vector store index where we are going to store the data. And then everything is happening in the backend after calling this particular method. They have written each and every line of code. You can go and check with the Hugging Face. Sorry, you can go and check with the GitHub of this Llama. So I hope, guys, this is fine and this is perfect to all of you. Now in the next class we'll explore about this hashtag, and yes, in a very detailed manner I have shown you each and everything. So guys, yeah, if you like this video, please hit the like button and stay tuned with me for the latest and the updated content. Thank you, guys. Thank you. Bye bye. Take care. Have a great day ahead. I will meet you soon in the next video. Until, thank you. Bye bye. Take care.